Hello, can you hear me? Hello, hello, hello.
Yeah, I can.
Okay, good.
Yeah, how are you?
Yeah, I'm good. You?
I'm also good, thank you.
Okay.
Yeah,
So last time we were, I think, analyzing chromatography. Was I right? Or
yes, yes.
yeah, and all of the other separation techniques.
Yeah,
We were doing those as well.
correct.
Hmm.
And this is what I also think. So, what topic is currently going on in your school now?
Actually, school's ended. It's the winter break, so I don't really know what we're gonna do afterwards. But then I assume we're gonna continue. I assume that we're gonna resume off from the same topic, so I think we can resume from separation techniques.
That's done. Like separation technique is done. So after separation technique, I'm not aware like what your school is
Okay,
going
sure. I'll
to do.
check our Moodle because
Yeah, yeah.
that's what's gonna be there.
Okay, so in separation technique, that's it. Later,
Yeah.
you have to tell me what the topics.
Ah, wait. Auntie. So we've done atom bonding and molecules. Then no, where is it? Separation techniques. Did we do ions, atoms, and isotopes? We did that,
Yes,
right?
we did. Huh.
Okay. What? Okay. What about C2, the periodic table? Yeah, we've done. No, we've done it. We've done it. We're mainly just doing C1. We could do this. Did we do the structure of an atom?
Yes, we did. Protons, neutrons, electrons, charges, all those things, right?
Yeah. Think we could review those,
Okay.
like structure of the atom, ions, atoms, and isotopes, and electronic structures,
Is that
just to
it
make
what you
sure.
have? Okay. Okay, sure. Ah, why is this doing this way? I'm unable to write over here. So I will stop sharing and I'll share some other link. I'll share you a concept board link, okay?
Yeah.
Okay, structure of atom. Like atom consists of three basic constituents. I'll share a new
Have
board
you
link.
shared the concept board link?
No, no, no.
Ah.
It's loading for me. Yeah, here it is.
Ah, yeah, found it.
Done. You're on it, right?
Yeah, I'm here, I'm
Okay.
here.
Yeah. So we will revise structure of atom is what you mean?
Yeah, we can revise the structure of the atom.
Okay. So basically, if you take any atom, what does it contain?
It contains a nucleus and then there's outer shells.
Okay, is that it?
Okay, so in the nucleus there can be protons and new there can be protons and neutrons, whereas on the outer shells there can only be electrons.
Yeah, in the center you have protons and the neutrons, then you have the shells around it
Okay.
where you find the electrons.
Okay.
Okay. Nucleus.
Here, just one second. Let me copy that down.
Okay.
Yeah, I should copy this down afterwards. Structure of atom. How do you determine an element's atomic number?
By counting the number of protons.
Ah, so in the diagram, the blue ones are the protons and the white ones are the neutrons.
Yes.
Then the red ones are the electrons.
Correct.
The electrons are in the outer shells and the protons and neutrons are in the nucleus.
Right.
Can an element have the same atomic number but a different number of neutrons or electrons?
Neutrons possible.
Electrons? Like, let's say if you have two of the exact same elements, they have the same atomic number, but then they have a different amount of neutrons and electrons.
Yeah.
That's possible.
Can you come back? Same number of?
Same number of protons, but then a different number of neutrons and electrons.
If no, that's not possible. Neutrons different are possible, but if the electrons are different, you call them as ions.
So if the electrons are different, then you classify that as an isotope.
Yeah.
What if it was for neutrons? Would that also be classified as an isotope?
Yeah.
Because it really doesn't do anything.
Oh, what do you mean by really doesn't do anything?
Because, like, it has no effect.
Okay. Same
Ah,
number of
okay.
protons, different number of neutrons.
Wait. Mass number minus atomic number is equal to the neutron number. Okay. So when you're going through the isotopes part, they have to have the same amount of protons, but they can have a different number of neutrons or electrons. Is that true? Oh, yeah, or both as well. Same number of protons. What'd you write in the bracket next to it? Same number of protons. What'd you write?
Same number of protons,
Bracket.
same atomic number.
Different number of neutrons, neutrons, electrons, or both.
Same number of protons and the electrons, but different number of neutrons.
They have to have the same number of electrons as well.
Huh.
Okay. Then what'd you write
Yeah.
in the rhombus?
Example.
Example, okay. What's 6n and what's 7n?
Neutrons.
Oh, oh, okay, okay. So, Yeah, we can continue now.
Okay. Any doubts here?
No.
Okay. Now, if I give you an example, say are these isotopes justify?
Okay. Are these isotopes? Yes. No.
Why?
The mass number really is the mass. It's because the atomic number is the same, and all of the and in order for it to be an isotope, it has to have a different number of neutrons, but the exact same number of protons and of protons.
Hmm.
And if you have the exact same number of protons in in each isotope, that means that counts as an isotope.
Hmm. Same number of protons, different
But
number
if
of
the
protons.
mass number was the same for every single one, it would not classify as an isotope.
Yeah.
And
That's
diatomic elements are elements that travel in pairs, right?
yes.
Okay. Okay. Yeah, you can move on.
Okay. So this one we can say that same number of protons, different neutrons.
Same number of protons, different
So
neutrons.
they are isotopes, right?
Isotopes. Yeah, I've already explained that.
Yeah. I'm just writing this one. Any doubts here?
Yeah, no doubts.
What are their properties? As in, what about their
What,
properties?
what are their properties?
Huh. What about their chemical and physical properties?
Chemical and physical properties of isotopes.
Physical properties are similar, sorry,
Okay.
different, because they have the same different mass. Like mass could be different, density, boiling point, melting point, all these are different. But if you see the chemical properties, because they have the same number of protons, the chemical properties are similar.
Physical properties are different, chemical properties are similar.
Yes.
So physical different, chemical similar.
Mm.
Their chemical properties are the same because they have the exact same number of protons, right?
Hmm. Done?
Yeah.
Okay. If I take an example of chlorine 1735 and chlorine 1737. List out the number of protons, neutrons and electrons in both of them.
Okay. So from what you can infer, there are 17 protons in both elements. Then if you do 35 minus 17 in the first one sec. Yeah, if you do 35 minus 17 in the first isotope, you have 18 neutrons. Whereas on the other side, you have 20. Then the amount of electrons. The amount of the electrons are the same as the amount of protons, right? So then there are 17 electrons in each one.
Okay. So you mean to say 1717? That's the number of
Seventeen,
electrons.
17. Then there's 18, 20. It's 7. Okay, wait, I'll fill it out. You know what?
Okay.
17. 17. My bad. 18. There. I'll just copy this down. Yeah, you can continue.
Okay. So can we call this as isotopes?
You can call this as an isotope.
Then ions.
Ions. Ions is when it has the same number of protons but a different number of electrons.
These are the charged particles.
Or charged particles.
Atom is neutral. If there are charged particles, then you call it as ions.
Atoms are neutral. Proton or charged particles, atom is neutral.
You have two types of ions basically. One is
Okay.
cation, the other one is anion.
Ions, charged particles. I'll mute myself. One second. You can move on, miss.
Okay, I have written something. Have you seen that?
You're uploading an image?
No, cation, anion I have written. Have you taken it down?
Yeah, I've written it.
Okay. So will you be able to find out what is the number of proton electron? I mean, what is the number of proton electron in case of ion? Is that possible?
It's neutral.
Okay. Wait a minute.
Proton, the number of protons and electrons they have is the exact same, yeah. What did you write? Species?
These are the ions that I'm going to give. You have to fill this. Say if I say, um, let's consider one example, aluminium 1327. You have to fill this. Okay. Whatever column is blank, you should fill it. Yeah. Fill whichever the blank. Whichever is blank, you have to fill that. Are you filling it? Are you filling it? Hello.
Yeah, I'm filling it, miss. I was muted.
Oh, okay.
Miss, for the second one, I can't seem to find an element with a mass number of 15 and an atomic number of 7.
But atomic number, if you get, that should be fine.
No, like I'm doing the second one.
Yeah, but atomic number, if you do, that should be fine. Mass number,
Atomic number is 7, the mass
uh,
number is 15. I can't
yeah.
seem to find any element.
See, atomic number is what you have to search. The isotopes will not be mentioned in the periodic table. You have to just go ahead with the atomic number.
Uh, is it lithium?
Atomic number 7, is it?
Yeah. Is it lithium? If it has an atomic number of 7?
Lithium is not. The mass number is 7.
Oh, yeah, it does. Is it nitrogen? It is?
Correct.
Okay, 15 over 7. Yeah, I'm going to the next one. Okay, so for the first one, there's a proton number of 13, a neutron number of 14, and an electron number of 13. Then for the second one, the element is lithium. I'm doing the third one.
Okay. Element is lithium.
For second one,
Atomic number 7 cannot be lithium. Lithium has the mass number 7. Atomic number 7 would be nitrogen. That's what.
oh yeah, it's nitrogen. It's nitrogen. Okay. So proton number is 26. Neutron number is 30. Neutron is 24. atomic number 26. For the third one, is the element iron?
Yes.
Okay, that's great. Then for the fourth one. Okay, how do you do with the fourth one? Because both of them are one.
So what do you do in that case?
Just write one for everything.
Yeah.
Well, that was simple. I
What
didn't
about
even
the
have to do.
neutrons? What about the neutrons?
What is it supposed to be, a decimal?
No, it can't be.
Then how do you. So it has zero neutrons.
Zero neutrons. Yes.
Does it have to contain a neutron, or does it not? Any element?
Need not.
They don't. Ah. Okay. We do know the element is bromine, so we have to divide it. Fe5626. I did that one. The last one, bromine 2235. No, that looks like 86. Minus 35. Okay, I'll fill the table out.
Hmm. What about the charges?
The
Where did you
charges,
fill?
oh, it's
Where did you fill?
negatively charged.
Won't you be able to draw on the screen? Right on the screen.
Okay, how do you do the how do you do the last one?
You find the
The
number of
last one.
electrons. Only the number of electrons.
35.
35 protons.
35 protons.
Hmm.
Then there's 45 electrons.
Huh.
No, 45 neutrons.
Hmm.
So zero electrons. I don't know. Plus,
Rest all. Are you going to fill in this?
oh yeah, I have to fill it. I have to fill it. Okay. Uh, I can't draw much. I think I'm finished. Yes.
Yeah. But the charges, what about the charges that you are going to write?
Oh, I can't. Oh, I don't know the charges.
Okay, see, 7 protons should be 7 electrons, but it is 10. That means to say 3 more. So it will have 3 minus charge.
Oh,
So can you
okay.
write for the next one then?
Okay. How do I add some text? 2 minus. Yeah, I've done it for iron
Why is it 2 minus?
because the number of protons is 26, the number of electrons is 24. For iron,
So isn't it 22 plus instead of 2 minus?
shit. 2 plus. Okay. Then for aluminum, it's neutral, so it doesn't have any charge. It's not a cation or anion. For bromine, I don't really know how it's a negatively, how it's an anion. Apparently, the electrons are supposed to be bigger than the amount of protons, but then I really don't know how because I really don't know how to calculate the electrons.
Okay. But rest all right. Here you see 1H1 plus. That means to say this has lost electron, so it's 0 electron. It has gained 1 electron, so it should be 36.
Oh, so if it's plus, wait, how is it zero for the hydrogen one?
Plus 1. That means to say it has lost 1 electron.
Oh, okay, wait. So like if it's like say, so if the thing next to it says like say 2 plus, it means it's gained 2 electrons.
2
But
electron
then when it
lost.
says 2 minus, it says it loses an electron.
No, no, 2 minus is gains 2. Minus is always gains. Plus is always loss.
Okay. Yeah, thanks.
Any doubts about it?
Yeah, no doubts.
Okay. Then in that case, if you have any um, atom and you should be able to write its electronic configuration. Are you aware of how to write the electronic configuration?
Electronic configuration. Yeah, I've heard of it. You're supposed to arrange the atom.
Arrange the electrons.
Yeah, you can say that. Loose. E minus is the symbol for electron, right?
Ah,
Okay.
okay. So if this is a nucleus and there are different number of what you say electrons that are going to be filled in each shell. Okay,
Mm.
these are the different shells and you have inside very much pretty much inside you have, this is the place where you have protons and then neutrons. This becomes the okay, if you consider this is the first shell, this is the second shell, then comes the third shell, then comes the fourth shell. You do not have to worry about fourth shell, but according to your curriculum, the first shell can maximum hold 2 electrons because it's very small. Second shell can hold 8 electrons. Third shell can hold 18 electrons. Fourth shell can also hold 8 electrons. This is according to your curriculum, but actually third shell can hold maximum 18 number of electrons, but you do not have that.
What about the
Fourth shell
fourth?
can, fourth shell will have 32 electrons. You do not have that. You have only till 20, atomic number 20. Okay, so the first shell will have 2 electrons, second shell will have 1 2 3 4 5 6 7 8 electrons, third shell will also have 8 electrons, the fourth shell will have 2 electrons. This is still atomic number 20. You just have that, not more
Yeah.
than. So this is how you arrange the electrons. Do you have any doubts in this?
Yeah.
If I have Li 3 7 plus, let's consider this one. Can you draw the structure?
Okay. So yeah, go. So protons are 3, neutrons are 4. Why do you keep on drawing it? Am I your phone? Won't it be 3 4 4?
Hmm. Why? How?
Is it gonna be 2 2 then?
2
Because there are
2.
3 protons and 4 neutrons.
Draw this in the circle form once. Whatever you are saying, just draw it in the form of circle and arrange that properly.
Okay. Okay. Just 1 second. How do Why do I keep on? No, I have to write it on the far side. I'm not an artist. अभी तक नहीं.
How many electrons are you going to fill?
There
Okay,
are 2
3 and 4
electrons
are
in the
done.
first shell and 2 electrons in the second shell.
3 is the number of electrons. 3 and plus 1 in the sense it has lost. So there should
Yeah,
be
so
just...
then it has 4 electrons.
No, 2 only.
Oh yeah, plus is oh yeah, plus is minus.
Yeah. So the entire outermost shell will not be there like this. This is it. You have to say this is the nucleus. Okay. So how do you write the electronic configuration? You just would mention 2. If it is Cl minus, as I said, Cl is 17, it will gain 1 electron 18. So you would do 2 comma 8 comma 8. 2 8 8 is 18.
Yeah.
This is how you write. Are
Okay.
you clear with this?
Yeah, I'm clear.
Do you have any doubts?
Hmm.
Okay. If you have any doubts, you just ask me.
Yeah, sure.
Okay, this is about the atom. What else?
This is about the atom, atomic structure. Oh yeah, let me go to the other ones. So what else is there is we study about group 1 and group 7.
Group 1 and group 7. Okay.
The alkali metals and the halogens.
Okay. Fine. We just have 2 minutes to wind up.
So we can...
Sorry, alkali metals, right?
Yeah.
What do you know about
And
them?
you already know that the alkali metals are very reactive. That's one thing.
These are group 1 elements because they have one outermost electrons. Outermost electron. They are highly reactive.
Also, the group number tells actually how much outermost electrons they have, right?
Huh.
Oh, okay.
They lose one
And they're
electron to
very
have plus one
reactive.
ions. Yeah. Very reactive. That's why they are stored under oil.
So that you can prevent it from reacting with the air and water.
Correct. So we have lithium, sodium, potassium, rubidium, cesium, francium. Whereas francium is radioactive.
Francium is radioactive. Do you have to study francium for GCSE?
No, you do not have to.
So it's only lithium, sodium, potassium, rubidium, and cesium you have to study.
Yes, and out of them, you will be only given with the first three, I guess. Sodium, lithium, potassium, that's it. Nothing else.
Sodium, lithium, potassium. That's
Yeah,
it.
yeah,
Okay.
exactly. Yeah.
Okay. That's clear.
Okay, we shall continue this in the next lesson then.
Yeah, okay.
I will share the notes with you.
Okay, that'll be great.
Okay then.
So take care, miss.
Bye.
Yeah, bye.